The probability that we find using our test statistic is known as a p-value. So a p-value or probability is a number between 0 and 1, which indicates how likely something is. So the closer it is to 0, the less likely it is. So that means the smaller the p-value, the stronger the evidence against the null hypothesis that's provided by our sample mean and our sample data. So when we think about the frozen soda drink and we had a p-value or probability of 0, that's what led us to conclude that the company is not filling the drinks to 20 ounces, but instead those drinks are being underfilled. So when the p-value is small enough, it says that it's very unlikely that we get the sample data and sample mean we got if our null hypothesis is really true. So a probability or p-value of 0 makes the conclusion easy. But what if the probability isn't 0? How do we decide that? So suppose when I did this soda drink problem, I found that the probability that my frozen drinks were underfilled is 23%. So about 1 in 4. That's not going to give really great evidence that the company is shortchanging my drink. That's just too big of a probability that could be random variation. On the other hand, if I find that the p-value or probability that my drinks were underfilled is 2%, then I do have evidence that these drinks are not being filled all the way, because that's about a 1 in 50 chance that would happen. So how do we decide what is small and what is large? Researchers set a significance level based on the type of research. So they call that significance level alpha, and it typically ranges somewhere between 1 and 10%. So if no significance level is given, we use alpha equal to 5% or 0.05. So suppose we set alpha at 5% and we got that 2% result with the soda drinks. So that means my p-value is going to be smaller than the alpha. If the p-value is smaller than the alpha, we say that the data, the results, the differences are statistically significant at that level. This means the alternative hypothesis is more likely, and we're going to reject the null hypothesis. On the flip side, like a p-value of 23%, that's going to be a lot bigger than an alpha or significance level of 5%. So if that p-value is bigger than alpha, we say that the data are not statistically significant. In other words, we think it's maybe just natural variation. We don't have enough evidence against the null hypothesis, so our conclusion is that we do not reject the null hypothesis. So there are only two conclusions that you can get out of this, either reject or do not reject. So you can't accept the null hypothesis. That isn't a thing that we do in stats. So let me relate this back to the jury trial. If you serve on a jury, other than if there's a mistrial, the only conclusions that you can get are either guilty or not guilty. So not guilty would mean we fail to reject the null hypothesis because our null hypothesis is they're innocent. If we do reject the null hypothesis, that's when we're going to give a verdict of guilty. So similar to the guilty, not guilty, guilty verdict, your responses out of a hypothesis test are either reject the null or do not reject the null. All right, so let's take a little bit of a look at this picture. So you notice that we call this a one mean z interval, and what we're going to do in this chapter is a one mean z test. What that z is indicating there is that this is a normal distribution. So that's why I was able to use that Rossman Chance app to get those probabilities, because I'm still in that normal distribution. When we get to the next chapter, we're going to switch from a normal distribution, a z as in zebra, to a t as in tiger. So it is similar and it's related, but it is a little bit different, and we'll look at that in chapter 20. So for right now, if we're looking at this as a normal distribution and our p-value is smaller than alpha, what that means is that you are way out in the tails. And the further you're out in the tails, the smaller the probability or p-value. Means you have more evidence against the null hypothesis, so you're likely to reject it because the alternative hypothesis seems more believable. On the other hand, if the p-value is bigger than alpha, that means rather than being in the tails, you're closer to the center or the high point of the distribution. So the closer you are to the mean or the center, it means the larger the probability or p-value is going to be. You have less evidence against the null hypothesis, so you will not reject the null. That's a typo down there. That should say do not reject the null if your p-value is bigger. That means your alternative hypothesis is not believable in that situation.